All right, good morning, everybody, and welcome to another webinar by the UC Davis C-STEM Center. Before we jump into today's topics, I want to do another recap of the structure here. So to the right of the video that you have on YouTube there's a chat window. If you have any questions throughout this short webinar, go ahead and post them in the chat, and I will do my best to answer them as we are going through the topics. Keep in mind, however, there's a several second delay between when I say something and when it appears for you. So if it seems like I'm taking a little bit of time to get to your question, that may be a part of it. So, today's topics, we're going to dive into our grades 6, 7, and 8 math curriculum that are available through RoboBlockly, and just kind of do a quick overview of what's available so that you kind of have a better idea as you're preparing these online lessons for your students. First off, to get started, let's look at how you can get access to these RoboBlockly activities. First things first, if you go to our website, open up any web browser and go to c-stem.ucdavis.edu. It will take you to our homepage, and our website has tons and tons and tons of useful information on it. So I highly encourage you to kind of dive into our website, read around, see what we have on there. But anyhow, at the front page of our website, at the top here, we have this gold bar that says free resources for distance learning. If you click on that, it's going to take you to a new subsection of our website that we've been building out. And on the left-hand side of this page, we have a register link. And if you click on that register link, I'm going to give it a few seconds for this ambulance to finish going by. Okay, so if on the left-hand side you click on register, it will take you to a registration form. You can fill that out and you'll be sent an email with some more details about what resources we're offering, and then we'll also get you a full access RoboBlockly account set up. Once you've gotten your RoboBlockly account set up, you can go to a RoboBlockly, that's RoboBlockly.com. In the same web browser, I like to do it in a new tab because I like to open lots of different things and jump back and forth. But once you're at RoboBlockly.com, you'll see an environment that looks somewhat similar to this. Right now, I don't have the default settings set up, so give me just a few seconds to reset it. So these are the default settings, what you might look like the first time you visit RoboBlockly.com. And RoboBlockly is a web-based block coding environment that's really designed from the ground up to help us support students while they're learning math, coding, robotics, engineering, science, computer science. And so there's a very wide variety of features available through this platform. And we're just going to dive into a couple of them to start. So first things first, at the top here, if you're not signed in yet, you will see a sign in button. And if you click on that sign in button, it'll take you to our sign in page where you can type in your email address and your password, to log in to RoboBlockly. Once you're logged in, you'll get access to all of the additional features that are available here, starting with the curriculum portal at the top left. So this curriculum portal is where we're going to be working for the duration of this webinar. We're going to be looking at a number of different courses, actually 3 different courses that we have here in the curriculum portal that are organized sets of activities that build a scaffolding for your students. So they start out at the early activities that you might be doing and then build through all the concepts that you might see in a traditional math course. So if you scroll down on this curriculum portal, you'll see we have courses for robotics. We have Robotics 1A, 1B, Robotics 2. We also have courses for coding, Coding 1 and Coding 2. And then we have a number of math courses, kindergarten all the way up through Algebra 1 and Integrated Math 1. And these courses are constantly being adjusted and developed, and new activities are being added to them. We're refining activities based off of feedback we get for teachers. So as I'm going through these activities, if you have any suggestions or anything, you can put them in the chat, and we'll see if we can get additional activities added based off of recommendations that we see. Just below the math activities, we also have a number of courses that are part of our free curriculum. We have Hour of Code, AP, CS Principles, Arduino, LinkBot Arduino, which is more for sensor-based robotics. And then we have a number of projects that support geometry and art and animations and really going the next step with coding and robotics. So anyhow, to dive into the math curriculum for today, I'm going to start off by opening up 6th grade math here. If I just click on the image there, it'll open our 6th grade math course. And all of our courses are organized into sections. We start out with section 1 here in 6th grade, where it says we're going to be working with whole numbers and decimals. So we have a number of different activities to support this section, and then we go on to section 2 with fractions, and then rational numbers, and so on, all the way through this 6th grade math course. So at the top here, just a quick overview of the activities we have. We have activities for multi-digit operations, for finding the number of apples that have fallen off of a tree, so starting to work with a little bit more unknown values, doing calculations for number of candies that you have to evenly distribute candies. We have function machines for starting to recognize and identify if inputs and outputs, a set of inputs and outputs could be considered a function. And all of these are interactive activities that the students can go through on their home computer. And for RoboBlockly, you don't need a Windows or Mac computer. You can do everything from a Chromebook, from a tablet, from technically from your phone, but the little tiny screen might be a little bit challenging. So it's a very flexible platform and environment here that really is ready to go for use with this online learning that we're transitioning to. To get a little bit more details about any of these activities while we're going through, you can click on this little eye with a circle, and it'll pop open this additional information menu that says the activity ID, what subjects it's for, so this one's for coding and for math, the grade levels that it is flagged for, although it could also be used in other grades. It doesn't have to be 6th grade. The keywords that are associated with this, so addition, subtraction, and variables, any curriculum links that this appears in, so we have 6th grade math curriculum. It also includes the standards that this activity is appropriate for. So this one's good for writing, reading, and evaluating expressions in which letters stand for numbers. And then it also shows you the initial problem statement. So it says initially there are 13 apples in a tree by the lake. Some of the apples fall into the lake and 7 remain in the tree. Use the draw apple function to draw the correct number of apples in the lake. Then run the program and answer the prompt. And then it also gives a little bit of a hint saying, write an equation using a variable for the number of apples in the lake and solve for the variable. Below that, we have a bunch of different buttons here. We can go to the activity, so we can open up the activity as if we were going to solve it ourselves. We could click on initial prompt to pop open this initial menu. This is actually going to be phased out in favor of a cleaner problem statement. We could open up any hints that might be available for the students beyond the hints that are inside of the problem statement. We could look at the description of the activity. As the teacher, we could download a documented copy of the activity with the standards and any other supporting information that we have for it. And then we could copy the activity into our new own activity and start to build from that. And I'll talk more about creating activities in another online session in the future. So once I've looked through all the details of that activity, it'll give me a little bit of a better idea of what it is. And sometimes it might be easier to actually open up the activity and solve it myself. So moving along, just quick overview. We have a couple of activities here for helping the students get practice with fractions. So solving a fraction division maze or dividing pizza into fractions. We go into rational numbers where we have a soccer field on a coordinate plane, and we have to start working with the soccer ball and moving the robots accordingly. We go into ratios and rates, where we use ratios to calculate distance traveled, or how much lemonade is in a glass, or looking at proportional relationships, or starting to analyze tiles and grids to come up with all kinds of different pieces of information, such as how many tiles there are of a certain color, etc. Moving along, we also have a section on percents for drawing pie charts with percentages. We go into units of measurement, so converting, in this case, between kilometers and miles, but it could easily be expanded to any kind of unit conversion. We go into algebraic expressions in section 7, where we're writing and simplifying algebraic expressions or modeling solutions in a coordinate plane. And so we really are getting the students much more familiar here with what the x-axis is and the y-axis is, and how what we represent as an xy coordinate actually translates directly to something in the real world, because all of these robotics activities that we have here can also be done on a hands-on robot that you might have in front of you. Section 8, we talk about equations and inequalities, so looking at position versus distance traveled. We look at solving simple equations using the distributive property, starting to look at relationships between variables and determining what those relationships are given a set of data. We look at, section 10 goes into areas, so looking at the geometry of a square or a rectangle, or using combinations of shapes to determine the area of more complex shapes like we might see here, or to determine the area of this boat polygon, just by combining all these different shapes that the students are familiar with. And so it starts to become a much more dynamic multi-step problem instead of a simple area of a rectangle. We also are going to activities for solving for the surface area of a three-dimensional shape, or the volume of it, starting to have them create their own drawings to represent three-dimensional shapes or two-dimensional shapes. We go into data measurement, so analyzing statistical data about pairs of shoes, or finding means and medians of sets of data through histograms or other displays. So there's lots of activities here, and again, they're constantly being expanded and more added and developed to support the teachers. So if you see something that you'd like, or you can think of something that you'd like that you don't see here, put it in the chat, send me an email, we will get it added for you. Moving along, I'm going to go back to the curriculum portal. And once I'm in the curriculum portal, I'm going to look into now the 7th grade math and just quickly do an overview of that. So we have a lot of different activities for supporting integer operations here to really get the students familiar with what positive versus negative is, and starting to really understand that numbers represent a value, and that value can go in either direction on the number line, forward or backwards, and so it starts to get a lot more interactive with the practice we have here for integer operations. And then we start using those integers for different things, like changing the speed of a robot, controlling how far it's going in each direction, and so on. We also go into rational operations and getting rational numbers on a coordinate plane. We go into rates and proportions, so finding the speed of robots, having two robots race on a track with different speeds and starting to do different calculations with those. Looking at similar idea of robots moving along a highway with different rates, and looking at differences of distances. We look at filling different cups of coffee using ratios given the different geometries of the shape of the mugs, mixing drinks using ratios, so getting the right combination of lemonade to tea for an Arnold Palmer, for example. We go into using ratios to determine contents of a trail mix or a snack mix bag, solving and modeling ratios and proportions using distances. We look at plotting hours of sleep versus age, so we start to get a little bit more dynamic use of a XY coordinate plane here. We start looking at using simple fractions related to drawings and getting proportions of the size of elements on a face correct. We start looking at using proportions to effectively animate an hourglass so that it looks more realistic, like we might expect to see if we had an hourglass sitting in front of us. We look at using ratios to move robots at the same speed, look at having robots move the same distance or at the same time. We go into percentages, so looking at shooting with percentages, determining how many baskets you make, looking at two robots moving on a highway in opposite directions, kind of like two trains going opposite directions, and starting to look at those rates and proportions. We start looking at modeling equations and creating solutions for those equations using these little two-dimensional robots in this Cartesian coordinate plane. We look at representing inequalities on a number line. We're looking at representing them through simple things like a pie and a recipe. We look at modeling them on a horizontal line or even on a vertical line, and just starting to get the students much more familiar with the different ways that these inequalities can be applied. We go into geometric figures, so drawing trucks along this highway at varying scales so that they look realistic as this highway kind of fades out there. We look at using ratios to expand the size of this ball as it rolls, of the snowball as it rolls down the mountain here, and as it gets closer it looks like it gets larger, and it also collects snow along the way down. We look at using ratios to find the height of a building in two-point perspective here, so we're getting a little bit more related to drawing and art, and really starting to touch a bunch of different interest sets of the students. We look at running a timed football play, so coming up with different plays with multiple robots and executing those, and using a lot of geometry to determine the best courses or positions to get robots into. And so it really is bringing the math alive here with these interactive and hands-on activities. We also go through shading parts of a circle and starting to work with different numbers of degrees in that circle. We look at complementary and supplementary angles by actually moving robots around and seeing how they're represented here on this grid. We look into more details of surface area and volume of solids. We also look at the dimensions and properties of various flags to help support this idea of surface area and volume. We look at areas in the coordinate plane, going into more rectangles and trapezoids and other polygons as well. And then our activities get into probability, so looking at basics or calculating probability with random data sets. We get into analyzing and comparing statistical data, and starting to look at different properties such as the mean or the median or the maximum, etc., to start to build a much more solid understanding of these different concepts. Moving along, if there's anything for the 7th grade section that you didn't see as we went through this quick overview, again, put it in the chat, put it in an email to me, we'll get it added. We're constantly, again, developing and expanding these based off of feedback that we get from teachers that are actively using these activities. So moving along, if I go back to my curriculum portal, I'm going to do a quick overview once again of our 8th grade math, and then if I have a little bit more time, I might dump into the Algebra 1 and Integrated Math 1 for those students who might be ready for the next step. So in 8th grade, we have some activities for solving and modeling simple algebraic equations. You'll notice some of these are repeated from previous courses, and that's so that if you have a student who had used this for their 7th grade math course, when they start up with this, they get that little bit of practice with an activity they've seen before, become a little bit more familiar with what they're doing as a refresher and a reminder, and then carry on with new activities like solving and modeling multi-step algebraic equations, or starting to work through calculating slopes dots and plotting lines between 2 points, and getting into much more advanced usage of XY coordinates, and really understanding why we use a coordinate system and what a coordinate system represents in the real physical world, instead of just something that we write on paper. We go into looking at interception points and writing equation or graphing equations in slope-intercept form, looking at the differences between graphing horizontal versus vertical lines. We look at parallel versus perpendicular lines, finding the slope of lines, and so on. We look into the different relationships between angles. So we might trace the path along this triangle and determine the relationships between the different angles in this triangle. We look at plotting points and scatter plots and trend lines through bunch of different functions that we have here in RoboBlockly. We look at starting to use functions for moving the robots. So instead of just in straight lines, we might have the robot move in a parabolic form here, just to start to give a little bit more visual representation of what a parabola is and what it means to have a exponent in an equation here. We look at graphing functions given different relationships. We look at linear equations in slope-intercept form and graphing those equations with a robot and having a robot actually utilize that to move along a coordinate grid. We look at systems of linear equations. So instead of just one, we start working on solving systems and modeling systems of multiple robots moving together, much like students might see in a traditional related rates problem with like 2 trains or tortoise and the hare. We look at more hands-on interactive examples like buying things at a grocery store. We look at determining when robots might collide with an obstacle, and so we can start to do predictive measures with these. We look at linear equations in standard and point slope forms, and starting to create a model of various equations here, such as ducks lining up along the river here. We look at areas and perimeters of geometric shapes, so shapes of or areas or perimeters of a rectangle, of a magic wand that's at an angle, so we can start to do various calculations using the same geometry that we've been building up with since 6th and 7th grade. We look at maybe a spider doing a 3-dimensional line here and determining the distance or really the shape that it might create if it was a cubic shape here. We could create a Pythagorean shell, so starting to look at sequences of numbers as well, determining whether or not a triangle is a right triangle based off of the angles inside of it. And then we also might look at coming up with a different path through a coordinate plane to collect a bunch of different points, or eggs in this case, that have been scattered throughout a 2-dimensional coordinate plane. We also look at additional drawings and other activities here to just support a more visual representation of what we're doing with these basic math concepts. Then we get into some geometric transformations, so translating lines horizontally or starting to translate them vertically instead. We go into reflection, rotation, dilation, congruence. So we actually have the students start to draw these shapes and then mirror the shapes across maybe the y-axis or across some line, and start to really get a hands-on working example with this, because they're actively programming the robots to move through these different shapes here. We go through dilation for scaling shapes, or translation and rotation for starting to really compose more dynamic sets of shapes here. And then this all gets applied into drawings in the project section that we saw back in that curriculum menu. Section 13 here, we go through volumes of solids, so designing cylinders or looking at the differences in volumes between cylinders and cones and spheres, etc. We go into some simple equations with exponents and solving those. We go through more statistics and looking at data sets and really putting all of this into a direct perspective for the student, something that they hopefully may be able to relate with or at least experience with, and change little values or parameters of what they're doing and see pretty much instantly exactly how the different parameters are adjusting what they're doing. So I have a couple more minutes. I'm going to go through just really quickly also our Algebra 1 curriculum. Just so you guys can see a couple of the activities here, we have solving and modeling multiple step algebraic equations, modeling the positions in the coordinate plane, linear relations with velocity and time, linear relations in a coordinate plane, expanding upon that, and even more. So lots of different practice here with relations. We go into absolute value and inequalities with some hands-on examples. We look at linear equations in slope-intercept form using robots. We look at graphing functions and using that function machine again to get a little bit more practice. And then we look at translating those functions and seeing how that might look if we were to either scale them or move them. We look at linear equations in standard and point slope form. We look at solving for missing values. We go through calculations for like price per cup in a lemonade stand, reasoning and inequalities to make a pie, graphing linear inequalities and starting to shade different regions based off of inequalities. We go into statistical data analysis, so modeling and calculating average speed of robots based off of several different motions. We go through arithmetic sequences and geometric sequences and doing a little bit of drawing and animation with those. We go through multiplying polynomials together and starting to look at polynomial expansion and trees. And then we also go into plotting and solving polynomial equations. So maybe finding the maximum height of a baseball if you were to throw it up into the air, or maybe a projectile motion for launching a projectile on the moon, or a quadratic equation for motion for a link bot to move and start to model it in a little piecewise kind of function there. So that's a really quick overview of the 6th, 7th, 8th, and 9th grade curriculum that we have here in RoboBlockly. Really quick before I get off, I'm going to show just a couple more really neat tools that we have here. First, if you're working on any program here in RoboBlockly, say, for example, I was just driving this robot around and turning it. I could then go and click on the Save File button, and as long as I'm logged in, I can choose between saving the blocks, which are these blocks here, between saving CH, which is the written code that supports these blocks, the written CH code, or I could save the grid, which is the final picture that we see here, and then I can either save that to my computer locally, or I can save it into the cloud. So if I were to save the blocks into the cloud, I just really quickly want to show you what that looks like. So I saved it, and when I go into my file menu at the top left here, this is a cloud file storage that we have now that supports the RoboBlockly environment here. So I have a number of files that I've already saved here. The newest one is bolded here. You can see it's RoboBlockly5.xml. If I click on it once, it's going to give me a preview of what is in there, so I don't even have to load the full thing. I just do a quick click and preview of what I have there. I can right click on it and click launch in Playground, or just double click, and it'll pull up right where I was. So I can save my work wherever I was at and carry on from there. So that's going to conclude today's webinar. I thank you all so much for joining and helping or going through this quick overview of our middle school math curriculum with me. I'm going to hang around on the stream for a couple of minutes in case anybody has any questions. And I do want to let everybody know really quickly, there is tomorrow, we're going to go through a more interactive session where it's going to be a guided practice where we're going to go through the first steps of creating your first online lesson. You can register for this online professional development by going to our website, and in that distance learning page, the free resources banner that I had you click, the menu on the left hand side here, we have distance learning webinars and PD. If you click on that, we have a number of professional developments coming up, so you could register for the professional development tomorrow, or we're going to be going through some more interactive how to teach K-5 or 6 through 8 math online, or even 7 through 12 math or robotics with CSTEM Studio and written coding as opposed to the block language. And so these are open, they're free, anybody can register. They're going to be more interactive, they're going to be conducted through Zoom, so there will be a lot more availability for discussion and questions, and make it a more of a formal online professional development rather than this lecture style presentation webinar. So once again, I'm going to open up for any questions, hang out for a couple minutes, and again, thank you all for joining. All right, I don't see any questions coming in, so if you have any after the stream, you can email me at djryan@ucdavis.edu. I'm more than happy to help and answer those. Hope you all have a wonderful rest of the day, and we will see you next time.